Hello guys, welcome to Meds That channel. So today I'm starting the topic of RAAS system. The full form of it is Renin angiotensin aldosterone system. I hope you have heard about it, but it's a bit confusing and everything. So I hope I will be able to help you to understand it in simple ways today. So what is the work of this system? So first question we have, what is the work? So the work, this system help us to help our body to regulate the blood volume and the electrolyte balance and the systemic vascular resistance of in our body. The other question we have is why we need this system. For example, if in our body there is a decrease in blood pressure, and if there is decrease in blood pressure, there is a decrease in perfusion. Decrease in perfusion is like oxygen is not reaching to our tissues or organ in enough amount, which can lead to hypoxia or ischemia. And so we need to increase the blood pressure for it. In other ways, how can we increase the blood pressure now? We have this question. So we have the ways like to increase the blood pressure. Either we can increase the volume of our blood, and so that the cardiac output will increase, or either we can vasoconstrict the vessel to increase the blood pressure. How the vasoconstriction will help is when we vasoconstrict the vessels, so the resistance increase in our vessels, which will increase in blood pressure. So now we have the question how this system works. So from our liver secrete or made a protein named as angiotensinogen. So our liver made a protein angiotensinogen and it secrete it in blood, and from our kidney secrete prorenin, which will convert in renin, and this renin help in this angiotensinogen protein to convert it in angiotensin 1. It's happening all in our blood. So now this angiotensin 1 as in our blood, it goes through our blood, it goes to our pulmonary circulation. In pulmonary endothelial cell, we have angiotensin converting enzyme. Our pulmonary endothelial cells is having angiotensin converting enzyme, which help to convert this angiotensin 1 to in angiotensin 2. So this angiotensin 2 now is in our blood. It goes to its receptors, angiotensin receptor, angiotensin 1 receptor, angiotensin 2 receptor. So first this angiotensin goes to the blood vessels. First is going to blood vessel, it is vasoconstriction. It is doing vasoconstriction in our blood vessel. Then this angiotensin 2 is going to our aldosterone adrenal gland, and it is making it release aldosterone, so that now we are having an increase in aldosterone also. And as you know, as I told you before, how it is working is vasoconstriction is because of vasoconstriction in our blood, the resistance is increasing, because of which the blood pressure is increasing. This is the first way we have. The second way is the aldosterone. It is going to our kidney tubules and it is doing sodium retention. And as you know, the water follows sodium. So because of it, as the sodium is getting reabsorbed more and more, so the water is following it and it is increasing the blood volume now. It is helping to increase in blood volume, because of which the afterload is increasing and the cardiac output is increasing. So the same thing, because of aldosterone we are having sodium and fluid retention. And it also increase inflammation, oxidative stress and fibrosis. So but for now, just our main thing as RAAS, as I'm talking about blood pressure, so we need to know this very well, like how it is doing vasoconstriction. It is working on blood vessels and making them vasoconstrict, and it is going in adrenal gland now then, and from there it is increasing the aldosterone, because of which the because of aldosterone, now the sodium retention is there, and as water sodium follows sodium, so water is also getting reabsorbed more and more, which is leading to increase in our blood volume. So like this, there is second phase, it is increasing the blood pressure. Now it is also working on angiotensin 2 receptor. So angiotensin and angiotensin 1 receptor is excitatory type of receptor, and angiotensin 2 receptor is inhibitory type of receptor. So if this angiotensin 2 is working on this second receptor, it is increasing vasodilation, it is decreasing fibrosis, decreasing inflammation, and decreasing the cellular growth. But for now, in the future, you will, in the pharmacology, you will gonna know, like, okay, we are making the angiotensin RAAS inhibitors, so those RAAS inhibitor, or we are making angiotensin receptor blockers, so those angiotensin receptor blockers are selective for angiotensin 1 only, so that they will inhibit this, and they will inhibit this thing and first receptor, and making it dilate, making the vasodilation is gonna happen. Then there is decrease in aldosterone, because of which there is decrease in sodium retention and decrease in blood volume. So but for now, I'm not going deep in the inhibitors and of the pharmacology part. Maybe I will make another video about it. So let's come back to our previous topic. Then we have angiotensin 2. Then we have angiotensin converting enzyme 1 also, and we have the other enzyme, it degrades the angiotensin 2. So, and it degrades it in angiotensin 1 to 7, and which in the future this activates the MAS receptor. But like for the main RAAS system, which will maximally help you in your questions, this thing what I told you about, like our liver is secreting the protein or making the protein angiotensinogen, and then with the help of renin, it is converting in angiotensin 1 in our blood, and then by blood it is going to our pulmonary circulation, where the pulmonary endothelial cells are secreting an enzyme called angiotensin converting enzyme, which is helping angiotensin 1 to convert it in angiotensin 2, and this angiotensin 2 is going to its receptor and making the blood vessel constrict, increasing the aldosterone, increasing the blood pressure. And I hope you understand it now. And that's it for this video, guys. I hope I was able to help you understand this RAAS system, and I hope you will be able to solve your question more efficiently now. Thank you so much.